Okay, so today we're going to do a little scientific notation review. This is just a review, so if this seems all completely new to you, maybe you should look at the makeup work from the other lessons or contact your teacher. But we're going to go from standard notation to scientific notation and back. Okay, when we first talked about scientific notation, we defined it as this form, m times 10 to the exponent n. All right, now when we talked about m, it was number between 1 and 10. So that meant we had some form that looked like a digit and a decimal, or maybe it was a digit between 1 through 10 and things after it, or maybe just 1. All right, regardless of how it looked, this m looked, please note there is only one number in front of the decimal. All right, that's why we defined it as a number 1 through 10. All right, doesn't matter what was afterwards. All right, it came after the decimal, but you could only have one number in front of the decimal in scientific notation. Another thing that we pointed out was this n, this exponent, could either be positive or it could be negative. And that was really key in figuring out what the number would be when you're going from regular real numbers called standard notation to scientific notation. All right, now we first looked at was how to go from real numbers to scientific notation. All right, this was the first step. Now, some of you all might have had a little bit more trouble with this. All right, and this is the more difficult part. But there were 2 steps. All right, there were 2 steps. All right. It depended on what your number was, what you were looking for, what was given to you. So if I started off with a small number, so say I give you a number and it looked like this, 0.0035. Okay, that's just as an example. That is a small number. It's less than 1. All right. Now, to get this in the scientific notation, you have to follow a step below that. It says move the decimal point right. All right, move the decimal place right until it is after the first number greater than 0. So we move the decimal right until it is after the first non-zero digit. All right, so looking at our little example right here, we see that if we move the decimal right, okay, the 3 is the first non-zero digit. So that is where we move the decimal to 3.5. Okay, so we have 3.5 now. Okay, then we put the times 10 stuff that we always have. Times 10 will always go there after the m, or the thing with the decimal. All right, and now we got to figure out the n, the exponent for the 10. All right, well, looking at our notes right here, it says n will be negative. So any small number or a number less than 1, a decimal number, all right, we know that it's automatically going to be a negative number. All right, so we just put a negative sign there. Okay, and it's going to be negative n being the number of times that you move the decimal. Well, I moved the decimal 1, 2, 3 times, so this is going to be a negative 3. All right, this is a negative 3. So 0.0035 in the scientific notation is 3.5 times 10 to the negative third. All right, let's take a look at our next rule. All right, if it's a big number, so greater than 1, all right, a number that look like that would be 1900. Okay, decimal right there at the end. All right, what do we got to do? Well, the rules state that we move the decimal now left until it is between the last 2 numbers, between the last 2 digits. All right, so we're going to move the decimal left until it's between the last 2 numbers. Well, here's between the last 2 numbers. 1 and 9 were the last 2 numbers, and the decimal has to go between them. So I now got 1.9. Okay. Well, what about those 2 zeros? Do I write these right here? All right, and we know there's no rounding when we are talking about scientific notation, but those are just placeholder zeros in this aspect, and so we don't need to put those. All right, those are just placeholders. They're not significant. All right, the next step is we got to put that times 10 stuff that we always have, and now we got to figure out our n, our exponent for the 10. All right, well, the rules say here that n is going to be positive for big numbers or numbers greater than 1. So, okay, it's positive. But n is still the number of times we moved the decimal. Well, we moved it 1, 2, 3 times. So I'm going to put a 3 up here. All right, so these are our rules that we have to follow to go from real numbers to scientific notation. We're going to do 2 more as practice before we go on to the reverse of this, going from scientific notation to regular numbers. Remember, small numbers. And also state, it says for small numbers, move the decimal point right until after the first number greater. And it says I need to move the decimal point left until it is between the last 2 numbers, the last 2 digits. So let's go ahead and look at this as if we're working it out together. All right, the first problem, all right, we first could probably figure out is this a small or big number? All right, well, it's less than 1, so this is a small number. All right, and according to our, we're going to be negative. So we're going to have a negative n. Okay, so let's go ahead. The rule is 0. Okay, so we're going to take this decimal. We're going to move it right until after the first non-zero digit. There it is. There's that first non-zero digit. So now it's after the 5. So I have 5.791. Remember, we're not rounding, so you're not putting 5.8. No rounding is allowed right now. All right, we're going to put that times 10 stuff that we always have, and now we got to figure out our n. All right, just to point out, we said it's going to be a negative n because this is a small number less than 1. So we go ahead and put that negative sign there. And the value for n is the number of times we moved the decimal. So we moved it 1, 2, 3, 4, 5, 6. We moved it 6 times, so it is negative 6. So this number in scientific notation form is 5.791 times 10 to the negative 6. All right, let's focus on the second one. All right, we have a big number. It is definitely greater than 1. Okay, so it's a big number, which means that we're going to have a positive n. All right, a positive n. All right, so the decimal is there at the ending. All right, now the rules. So I'm going to move the decimal left until I get to the not the very end, but between the last 2 digits. So 1, 2, 2, 2, 2. Right there, between the 3 and the 4. Those are the last 2 digits. So I have 3.4. Okay, I put the 0, 0, and the 4. All right, those are important. These 3 zeros, you don't necessarily have to put because they were placeholder zeros, all right? But all of this is important right here, so we put that down. All right, the next step is we put that times 10 stuff that we always have, and now we got to figure out our n. It's positive because this was a big number, and the value for n is how many times we moved the decimal. 1, 2, 3, 4, 5, 6, 7 times. So I put a 7 for my n. All right, I put a 7 for my n. All right, so we did 2 examples of going from real numbers to scientific notation. And now we got to go the other way. Like, so example right here above the 10. All right, that's my n. How to put it in reverse. All right, well, I think most of you all found out that this was a little bit easier, or you will find out it's easier to do. All right, and we just followed these general rules. All right, you first look at the sign of n. So you look at this exponent, all right, which we called n, and we have been calling n. All right, and it tells you which direction and how many steps to move the decimal. All right, so a positive n. So if I look at the n, the thing, all right, I'll look at that, and if it's a positive exponent, I'm going to move the decimal to the right. So opposite of what we did to put it into scientific notation. This is going to create a big number, or a number greater than 1. All right, a negative exponent means I'm going to move the decimal place to the left now, which is going to make a small number less than 1. All right, so we're doing the reverse of what we did to put it into scientific notation. Now, we don't necessarily have like other rules other than these two statements, and they could be summarized down into positive ends make big numbers and negative ends make small numbers. You keep that in mind, you're not going to screw it up. So if I have 1.0 times 10 to the 4, all right, we see that the 4 is my n, all right, it's positive. It's going to make a big number, a number greater than 0. Or greater than 1, excuse me. So I'm going to move it 4 times to the right. 1, 2, 3, 4. New decimal. I put zeros in to fill those gaps. So my new answer is 10,000. You could give me that in dollars, please. All right, negative ends make small numbers. So what if I had the same thing, 1.0 times 10 to the negative 4? All right, a negative exponent means I'm going to move the decimal place to the left. I am now going to make a number less than 1. So I go 1, 2, 3, 4. I put the decimal there. I got gaps, which I fill with zeros. So my new number is 0.0001. All right. This is a small number. It's less than 1. So positive ends make big numbers. Negative ends make small numbers. All right, so let's go ahead and do 2 problems for an example. Okay, so here we go. We got 2 problems. We got to take these scientific notations and put them into real numbers or standard notation. All right, so looking at the first one, all right, please note this is -4. All right, this is a negative n, which means it's going to become a small number, less than 1. So I'm going to take that decimal and move it to the left now. 4 spaces, because that's what the value of n was. 1, 2, 3, 4. Put the decimal right there. I got 3 gaps to fill with zeros. So my new number is 0.00047. Okay. That's how we do small ones. All right, I move the decimal left, and I make a small number because n was negative. Well, this one, n is positive. That's a positive n. And so I'm going to make a big number, or a number greater than 1. Okay, so I got 1.09. And I'm going to move the decimal 9 places to the right. That's a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9. I almost lost count right there. It's too much for me to count. Ran out of fingers and toes. All right, well, we have a lot of gaps that we got to fill with zeros. All right. All right, so what we get is 109 followed by 7 zeros. Wow, that's a lot. All right, but those are our 2 examples for going from scientific notation to regular numbers. Okay, we've reviewed both. We went from real numbers to scientific notation and backwards. So view this video if you need a review and while you're doing your homework and get ready for the quiz.